there, I'm Alexandra DeLazio, and I work at the University of Pittsburgh in the Department of Rehabilitation Science and Technology within Pitt's School of Health and Rehabilitation Sciences, also known as Pitt SHRS. And I am a research engineer. I'm a bioengineer, a medical product engineer, and a mechanical engineer. And that's what makes me a Pitt research engineer. But first, let's rewind a little bit. How did I get here? Well, at one point, I was in your shoes. This is a throwback photo from when I was in grade school and high school, and I participated in various activities that kind of led me to this moment. So I was in the Future City competitions, locally and nationally. I participated in the Pennsylvania Junior Academy of Science competitions, or the PJAS science fairs. I did lots of hands-on projects throughout my grade school and high school career. Took several trips to the Carnegie Science Center, loved every one of them, and took a ton of science and math courses that really prepared me to go into my college career. And that's where I went to the Swanson School of Engineering at the University of Pittsburgh, and I earned my Bachelor of Science degree in bioengineering with a concentration on medical product engineering and a minor in mechanical engineering. I thought I was done with school after that, but then as it turns out, I went back to graduate school at Pitt and earned my bioengineering Master of Science degree in Pitt's Medical Product Engineering program. And that's what brings us back to present. As a research engineer in the Department of Rehab Science and Technology. I work in the Tissue Integrity Management Lab here at Pitt. So let's take a look at a little promo video about our lab and what we're all about. And now that you got to see a little bit about our lab, I'll be expanding on that throughout this video to tell you all of the cool things that we get to work on a daily basis. Basically a day in the life of a research engineer. So we design and evaluate rehabilitation technology and look specifically at wheelchair cushions. We aim to improve the health and well-being of wheelchair users by looking at the performance characteristics of those wheelchair cushions. Our goal is to evaluate wheelchair cushion performance specifically related to pressure injury prevention. Pressure injuries can be really detrimental to wheelchair users and prevent them from participating in daily activities in everyday life. So what exactly is a pressure injury? A pressure injury is localized damage to the skin and underlying soft tissue usually over a bony prominence or related to a medical or other device. The injury can present as intact skin or an open ulcer and may be painful. You may have heard the terms before, such as bed sore or pressure ulcer. Those are other terms for a pressure injury. Let's hone in on a few specific phrases here. Over a bony prominence or related to a medical device or other type of device. So this is a picture of a person with a pelvis sitting on a cushion. We all have pelvises, and that means that we all have what are called the ischial tuberosities, which are basically your butt bones, and they are considered a bony prominence. The cushion, or the wheelchair cushion itself, is considered a medical device. So those two things are key factors in a pressure injury, as we just mentioned before. Coupled with the fact that pressure injuries often come into play with factors such as heat and moisture buildup between your bottom and the seat cushion, friction between your bottom and the seat cushion, as well as pressure on those, again, bony prominences. So the goal of wheelchair cushions are to prevent and protect any injury to those ischial tuberosities. But how many different types of wheelchair cushions could there possibly be? You're probably thinking that all cushions look like a foam slab or something similar to the couch that you see underneath the foam slab in this picture. The truth is, there's a ton of different types of cushions varying in construct and makeup and basically just how they work. Here's an example. Now this is a foam cushion similar to the one you saw before, except it's contoured, allowing for better distribution of pressure under your bottom and a contour for your ITs to fit right in between. You can see that here. Another type of cushion is a segmented air cell cushion. Now this cushion, if you look at the inside, is a series of small air-filled compartments that basically when you push down, the air redistributes and helps relieve pressure on your bottom and the ITs. The next cushion we can talk about is a squishy lattice cushion. This is very similar to the mattresses that you may have seen in commercials with Goldilocks, where Goldilocks puts an egg on the mattress and shows that it doesn't break. Now in this case, this cushion is just like that mattress, except instead of an egg, it's protecting your ischial tuberosities and protecting them from any type of injury by conforming to your shape. And last but not least, the last example for today is the clustered air packet cushion. So check out the inside of this cushion. It's a series of air-filled packets. Now those packets can be redistributed into different areas of that cushion to make a very customizable seating experience for the user. Now that you've gotten to see how many different types of cushions there are, you understand that we work with those on a daily basis. And here's a rough idea of what we go through on a daily basis. So with those cushions, we use a body analog, which is essentially an artificial butt. And I'll talk more about that shortly. We use that artificial butt with test fixtures that we build. We in turn then test our cushions and then disseminate information about the results and the statistics and the data that we find in order to help wheelchair users in the long run. As promised, let's talk about that body analog, which is known as a rigid cushion loading indenter, or RCLI. It's basically a wooden butt, and it's specified in what are known as the International and National Wheelchair Cushion Performance Standards, which are an outline of procedures that we have to follow when we run these tests. Similar to an experiment that you might run in your science classes, every experiment has to have independent and dependent variables and constants. This is a constant for us in our experiments. It's not going to change because we know it's wood, and it's not going to change, kind of like the way our bottom would change in real life. our bottoms are compliant and kind of squishy, which means they're very hard to predict. But a wooden butt is not, so that makes it easy for us to run our experiments and basically repeat them over and over again and get consistent results. On to the next step, building the test fixtures. So you can see here, I'm working on some building and projects on a daily basis. This is a typical test fixture. There's some key features in each one of our test fixtures. There's the cushion sitting on the bottom, the RCLI, which we talked about before, sitting on top of the cushion, an application of load, and the load itself. Now this is another example. You can see here there's the cushion and a heavy RCLI load sitting on top of it. Well, let's see what happens in this test. This test is known as impact damping. We'll talk a little bit more about that when we talk about our testing. This mimics a wheelchair user going off of a curb and the impact that they would face. This is an example of a cyclic loader. This is another fixture that we built in our lab. Let's take a closer look at the mechanisms that are in this. We have to pay specific attention to how to build these features. Check it out. There's a collar that basically pulls up on the indenter and the load, and then a spring that dampens every time it's pulled up, and it repeatedly cycles through and pounds on the cushion 17,500 times. This simulates real-world use of a wheelchair cushion. Another aspect of the building that I get to do on a daily basis is 3D modeling different parts. In this image, you see me building what is called the bulbous indenter. As you can see in the picture, this is what it turned out to be. It's an indenter with a series of 18 sensors on it. So there's some electronics work in the background that allows us to look at the pressure distribution over the bottom. And this bulbous indenter is actually made to mimic the human pelvis. You can see there that the distance between the trochanters, or your thigh bones, which are located on the side, and the bottom of your ITs is similar to that of a human pelvis. The next step in this process is the testing itself. Now the testing includes a series of different tests that we perform in our lab. Across the board, there are tests for pretty much everything you can think of, but we can only cover a few here today. So let's check out some tests. So we mentioned before about the impact damping test. We'll run that again. And the results that we see are the impact, or the acceleration with which that indenter, or the butt, falls onto the cushion as it goes down a curve or from an incline. We collect that data over time. Another example of a test is the lateral stability test. This is a test that we developed in our lab to mimic what's happening to the pelvis on a cushion during a lean or tilt motion. So basically, you can see on the top, this is what's happening to the pelvis, an off-centered load, and we mimic that on the bottom with the indenter and our test fixture. Another aspect of this test is the pressure map. It sits underneath of the RCLI, or the indenter, on top of the cushion, and it gives us an image of what's happening between the cushion and the indenter. The last step is dissemination. So spreading the word about all of the wonderful things we're learning about these cushions in order to help the wheelchair user. So we attend various presentations and share the information that we learn through papers and presentations. We also use our data to create fact sheets and infographics to help wheelchair users choose a cushion that's right for them, to provide them with meaningful and marketable outcomes that will ultimately improve their health and well-being. And that's a day in the life of a research engineer.